Dirty Scrap Podcast.
Yeah, so guys, thank you for being here on Dirty Scrap. I mean, this is the platform that we are using to give to the people as much as knowledge as we can about sustainability, about how the industry is moving forward and different type of technologies and input from CEOs, president of different companies. And today, Levidian, is that the right way to pronounce?
It is.
Okay, so Matt and Ellie, thank you for being here with us. And I want to start with some background. I want to women first, of course. So Ellie, I want to know about your background, how you get involved in all these crazy projects and how the life, bring you to this point.
Sure. My career started, I was a materials scientist. So I studied material science engineering at university, did a PhD in metallurgy, then ended up doing a few postdocs where I got to kind of develop new materials and advanced materials, and basically a materials geek by background. But really got into the idea of how you then take that out into the real world and commercialize it and make it a real thing. So I ended up going kind of leaving academia and going into kind of startup businesses that were working on commercializing new materials. And that involved kind of graphene and other sort of semiconductor materials as well. And so nowadays I work for Levidian, really looking at how we commercialize the graphene side of what we do, which we'll go into a bit later. But the graphene is a big part of the equation. It's a really high performance carbon material. You can do amazing things with it, and you can do millions of different things with it. And there's a bit of a challenge in what you should focus on, and we coordinate the activities between the sort of technical side of what we do and the commercial side of what we do, and the sales and what we're learning from the market thing. So it's a really interesting job to be in.
Right, and it's an interesting background. I am a material engineer as well. Not a scientific, but engineer. And I remember maybe maybe this was 20 or 25 years ago. I don't remember very well, but we have this news about someone identified the graphene, and they understood how to take it out of the, I don't remember, it was some diamond or something like that with a tape, so they can took it out from the surface, because it's a really complicated structure, right? How complicated it is? How complicated it is to manage this material, because I think it's very fragile, but it's very hard as well, right? It's more than diamond. Or can you explain a little bit more about the material? Because I think it's very interesting.
Graphene is very interesting. So it was actually discovered using graphite. So graphite is what's in your pencil. As you rightly said, they discovered it by using sticky tape. So
right.
They made this amazing discovery just with the really simple materials, and basically took a block of graphite and used sticky tape to peel away the very top layer of a single atom of carbon from that. And that is what graphene is. It's that single layer of graphite, really. And it's this hexagonal arrangement of carbon atoms that makes it incredibly strong, but also permits kind of electrical conductivity and thermal conductivity really readily. So it has very high electrical and thermal conductivities. And it's also incredibly kind of chemically stable as well. So it doesn't allow certain species through it. It is just a very kind of robust material. And nowadays it's made using a variety of methods. The key one is basically by putting graphite in a big blender with a load of chemicals that then breaks it into all of these individual graphene flakes.
Right.
A mined feedstock there that is very variable depending on where you get it from. So there are other companies working on building it from the bottom up, where you use kind of gas processes, CVD, that kind of thing, to build it atom by atom. And that's kind of more towards the way that Levidian do it. But yeah, it has this incredible range of properties. You get a very fine kind of black powder that then gets added into applications. So you can mix it in with polymers, concrete, batteries, and various applications, rubbers. We've worked on tires, paints and coatings. There's a whole range of things that you can use it for, and you just use it either as an additive or as a filler within those.
Right. And when you say CVD is like the chemical deposition process, that is pretty much similar to if I don't remember wrong, is PVD, that is on the plasma sputtering, similar to make like thin layers and all these different type of approaches.
Exactly, yes. It's like a lot of semiconductor processes. You start with a gas mixture and you kind of deposit atom by atom on the
Right.
surface of a substrate of some sort.
Nice. And let's talk about you, Matt. So what is your background and how did you get into this crazy idea about and here's the deal, guys. What we will talking here is just about the background, but we will talk about some technology that can change the approach that we have to green gas emissions and everything, right? So that's the main target. We will get into that topic later. But let me know about you, Matt, your background, how you get involved in all these different type of revolutionary ideas.
Well, I've been involved in oil field equipment production for nearly 20 years now. Just in the natural transition over that time, went from more typical oil field energy projects and transitioned into different green energy technologies. I've been involved in a number of startups, owned a number of green energy startups. And so scaling business development in more of the green energy sectors, kind of where I've lived for the last decade. So it's just a natural transition to step into a company who does both, right? Not only do we have this and produce this wonderful material, graphene, which has all kinds of incredible applications, not only obviously in aluminum, different smelting, but also oil field applications and enhance the products as Ellie suggested that oil field produce, like thermoplastics, etc. So it was just a natural step forward for myself.
And when you said that you've been involved for like the last 10 years in this green path, have you seen any like difference between 10 years ago and what we are seeing right now, not just on the aluminum industry, and because we talk more about the aluminum industry, but in the industry in general and on a global level, are you seeing any kind of difference that the industry is speedy, very fast in order to get into this green point? Or how do you see, let's say, the last 10 years?
Yeah, that's a great question. So in short, the answer is yes. The rate of change is quite dramatic. It's gone from resistance to the change. That's going to affect the business. That's going to affect the bottom line.
Right.
By making that change, by making that investment. And that's really where all major industry was 10 years ago, right? Not just smelting, not just oil field. And that's crazy. And what we've seen now in that progression was acceptance to adoption to now the mindset of everybody is going, geez, from an investor standpoint, I want to invest in green tech. We can see that climate change is definitely happening. This is a real thing. What can we do to help curb this? I need to make this part of my sustainable business practices in order to not only draw investment in, but in order to continue to be at cutting edge. And now we can see by decarbonizing to a certain extent, we can now take that carbon and make really useful enhancing products with graphene. I mean, that's the whole reason Levidian exists.
Right. And let me ask you a tricky question here, because I've been talking with a lot of different people. I have another podcast in Spanish, and we talk about sustainability, economic, and different type of approaches to different, industries. Here we are talking more about aluminum recycling and sustainability. One guy was asking me this, and I was like, okay, I don't want to go in that direction because I don't have enough knowledge. But he said, why do you think that CO2 emissions are bad for the planet when plants feed themselves from CO2 so they can grow more and more if you have more of this content in the atmosphere? And for me, it was like, okay, let me think about it because I don't have the answer. I don't know if you have it. It's a complicated and tricky answer because at the end, if you have more plants, you will create more oxygen. That is good for us, right? But if you are not reducing the CO2 emissions, you are helping to the global warming, right? So you are heating up the planet. So for me, it was like, oh shit, I don't know. So what do you think about this type of approach that people is thinking, okay, it's not true. We need more CO2 in order to grow the plants and to create more oxygen. But we are seeing all the changes in the world and all the industry going in that direction. So what do you think about it?
Look, number one, I don't think CO2 is a bad thing. I think that, we've seen in places where you don't see a tremendous amount of forestry. I know domestically here in North America, we've actually seen a lot of plant growth as a result. However, the amount of particulate put out in producing that and whatever it is, right? Whether it's through power generation or different processes of combustion, we are putting out possibly too much. And it does choke things out. I mean, Ellie had mentioned that when we pull out our carbon in the form of graphene, it comes out as a black powder. This black powder can block out certain amounts of sunlight, which plants also need. And I'm specifically talking about oceans, right? Let's talk about darkening oceans, everything else. So if we can pull some of that out and make it more useful, we're not saying carbon's bad. We're definitely advocates of carbon is good. We're just pulling out the carbon before it gets released into the atmosphere. Let me put it a different way. So I think everybody who's a natural gas user is not actually a natural gas user. Everybody there is actually a hydrogen user. So we look at carbon as a transport vessel to get hydrogen energy to point of use, right? Really what's burning, where the energy comes from, is the hydrogen. The carbon is then either released into the atmosphere or sequestered. So what we're doing is we basically developed a technology from its transport vessel prior to being used. And we take that carbon, we take that transport vessel, and we recycle it, we repurpose it into something far more useful, something far more enhancing, graphene. And so that's kind of our view. We all that energy that's there, we still allow that to carry on, right? Whether it's going into combustion for power generation, burners, what have you. That all that energy is still there. We're just disembarking that energy from its transport vehicle before that combustion. Right. So we're still big fans of oil and gas. There's different technologies now available to make it far more sustainable and really more eco-friendly.
Right. So now that you are getting into that topic, tell me about Loop and the technology, how this technology works, because as far as I understand, you are taking like the green gases, right? And you are separating the atoms or molecules, and you are creating graphene and hydrogen as a jet fuel or something similar to that, right? So that we can use it in so many different approaches. So tell me about the technology and then let me know how the technology works as much as you can, because I know it's a technology that you want to protect, of course, but I want to get into the process itself to understand, to the people that is out there seeing this, I want them to understand how the system works, what are the characteristics of the system, the benefits, and also what are those applications that we can put not just the graphene, but also the hydrogen that we are creating into the process.
I'm happy to say that one, Ellie, unless you would like to get in.
Yeah, I'll go for it. So our Loop technology, it's basically a plasma process that we use. So we take methane, whether it be as the natural gas supply to an industrial process or to someone's home, or it could be used as a waste gas. So it could be from landfill, for example, or it could be from wastewater treatment, or I'm blasting it with really high energy microwaves. So high energy microwaves are coupled to the methane gas that breaks the CH4 into the C and the H, and we get this soup of ions that is created, and that's the plasma. And then what starts happening is the carbon starts reforming as graphene within this plasma and then drops out. And what we get is graphene dropping out the bottom of the reactor, and then we get an exhaust gas which is hydrogen rich out the top,
right? And
our customers can either use that hydrogen rich exhaust gas as is, or they can further purify it into sort of 4.9 pure hydrogen for kind of fuel cell refueling, that kind of thing. So we work with a range of industries. A lot of our customers are kind of hard to abate industries that really struggle to move away from that natural gas supply as for example, a heat load in a furnace or something like that. And we give them a really convenient way to convert that natural gas supply over to hydrogen and then use that carbon in various applications to basically pay for that process. We drive further value and further CO2 reduction by using the graphene in products and in processes, and that's what we're doing with aluminium.
What are the advantages that the people, for example, on the aluminum side can have in changing natural gas for hydrogen on your process? And you have an idea about the calorific power that you have, this hydrogen that you are producing right now?
Mm-hmm. So the calorific value of gas in versus gas out is roughly the same. So we don't change that. The only input into our Loop unit is electrical energy. What we're using the graphene for is we're adding it into the anodes for the smelting process, which is driving basically better efficiency in the smelting process. So the graphene, when you add it in sort of less than 1 weight percent amounts into the anode, you can increase the electrical conductivity. It becomes less power hungry, so you can save whole percentages of energy in that, and that's quite significant for an aluminium producer. But you also drive things like less reactivity of the anodes. So the graphene, 1, makes them more dense, and 2, makes them less permeable to air. So the unwanted reactions that are happening with air in the smelter are either slowed down or almost stopped. And what you're getting is a longer lasting anode as a result of that, because the carbon consumption's gone down.
Right.
But you're also not producing as much dust on the bottom of the smelter. So the cell can last longer and perform more efficiently over time. And then we're also increasing the strength of the anodes by adding in graphene.
Right.
So that again makes them more robust, more resistant to thermal shock, means that you got less anodes breaking off over time and less cells having to be shut down over time. So that's a lot of cost recouped through that. And we also get performance and processing gains as well. So you can make the anodes themselves more tolerant to raw materials input. So you get things like less sticking of the packing coke to the anode during production, which means that a guy doesn't have to stand there and chip off the stuck packing coke for ages. So you get labour savings and things as well.
Right.
So just by adding in, so you can basically strip the graphene out of the natural gas that is feeding the baking ovens for the anode, throw that into the anodes, drive all of this performance and efficiency and energy savings and CO2 savings as a result of that, and then use that to pay for that initial conversion over to hydrogen. So it just works perfectly as a whole loop.
Wow. Well, I mean, this is a very unique approach, because at the end what you're doing, and correct me if I'm wrong, but it's helping the primary aluminum industry to not die soon, because everyone wants to go into the recycling side, right? What experts are expecting is that 90% of the aluminum, actually it's 95% of the aluminum that we will have in the market by 2032. And I don't think it's going to be that fast, but this is what they are saying is it's going to be recyclable aluminum, not from the primary sector. I don't think this is going to be that fast, because we need a lot of primary aluminum in order to get into those numbers, right? But the problem with the primary aluminum is you create a lot of CO2 out of 1 ton. I think if for every ton of aluminum that you are processing on the primary side, you are creating more or less around 16 up to 20 tons of CO2, because you have a lot of energy intensive, right? You need to put a lot of energy, electricity into the process. The anodes, they don't last too long. So what I'm seeing right now is you are creating hydrogen that can be a source of fuel, of power, but also you are creating a material that allow this primary industry to get better, to reduce the CO2 emissions, to make more aluminum out of what they already have, to have a better useful life, to reduce the labor, so you can push this industry to help the recycling industry as well. It's more or less that, oh, wow.
Very well put. Yeah, exactly. Anything we can do there that helps on the primary production side of things, I think is going to help the whole industry to decarbonize faster. And help it to survive better, and remain profitable.
And from the stoichiometric point of view, how much graphene can you take out of, I don't know, 1 cubic meter of gas, or how do you work with this?
So the figures are, so if we put, let's say, so our Loop 1000 module would process about 150 meters cubed per hour of methane. Out of that, you get about 27 kilos of graphene per hour. But what we'd propose to do, so our Loop 1000 module, and that's our first kind of commercial scale loop unit that will be available next year. What we would actually do with the aluminium producers is work on a kind of custom built facility that would process the amount of gas that they need to process and produce the amount of graphene that they need to use based on the scale of their operation. And we understand, every smelter is going to be very different in terms of, the energy supply they get, the CO2 content of that, the cost of that. So we have to work kind of on a tailored basis with each of them to figure out what the right scenario is for them for graphene supply and loop deployment.
Right. And at this point, do you have any idea about, for example, the savings that the primary can get using, for example, your anodes instead of the regular ones that you're using right now? Or do you need to go and make those tests on a pilot plant on a primary smelter and then try to understand the process very well and what are those benefits?
So we have a pretty good idea what at least the minimum savings would be. There are some things we can't quantify until we do a full smelter test. So right now, we and our customers are at the kind of pilot scale anode testing just to kind of prove it out. What we understand is we can definitely save energy by increasing the conductivity of the anodes, and we can definitely save, basically prolong the life of the anode. So you get a few extra days of anode life, which saves you basically in materials cost. And we've modelled out what that would be worth for a 500,000 tonne per annum aluminium smelter. And it's about $18 million a year that we would save just by putting the graphene in. And then, of course, on top of that,
$18 million.
18, yeah.
Oh, wow.
And then, of course, on top of that, you've got a whole raft of savings from cells that you haven't had to restart as frequently, from kind of more efficient performing cells over time. The labour savings we discussed, there's a lot more that we can add on that we can kind of flesh out, but that's kind of a minimum kind of worst case scenario.
Right.
On top of that, you obviously have carbon credits that you can get, and depending on how you participate at what government level, whether it's federal, state,
right.
There are all kinds of incentives for technology to bolt on right now to help you decarbonize, which you've talked about on pre-podcasts. So your ROI on equipment like this can be very, very, again, depending on what incentive programs you're involved in at what particular time.
Right. And I can see that Ellie is more on the technical side, right?
Very much so.
Right. So, Matt, I can imagine that you are on the business development side or on the project management side. How easy is to introduce these new technology into the industry? Is easy or it's not that easy? How was this path trying to, communicate all these advantages that you will have with this technology? But obviously, you need to go with those primary guys that been there, like they are dinosaurs, right? They've been there like for years and years using the same technology, and they are not changing too much. How easy or how hard is that path?
It's certainly a process, but as you mentioned, we have just some brilliant team members like Ellie who make breaking in there far easier. For us at this point, it's not really a sales process. It's more of an education process and an awareness process. And that's really where Levidian North America, that's kind of our path right now, is more of an awareness campaign while we continue to set up our facilities here domestically. We're going to be adding new R&D facilities in. So this is kind of where our focus has been, is more on making people aware of not just what graphene can do, but the loop technology as a whole, and then putting an infrastructure behind us, a support network within the United States to be able to support. And we have a nice robust support network across the US to be able to service the equipment. So, but to answer your question, once people understand a little bit better what it's about, they actually become quite receptive. And we've got a number of people we're in talks with, and the level of engagement is for us exciting.
Yeah, I think we found it quite interesting because I think, as you said at the beginning, Julio, the industry has this impression that decarbonisation is going to cost them something, and we're offering them a solution that doesn't cost, that actually becomes profitable over time. So we've been to events where there's been a lot of talk, and it's actually really reassuring to see just how engaged the aluminium industry is with this decarbonisation journey. But a lot of the talk is about, these are the steps we need to take toward meeting the goals. This is how we measure them, and this is what we can do. But a lot of them are kind of hanging on for electrical grids to be decarbonised as part of that strategy. Nobody before us kind of stood up and said, we can give you another option, and we can decarbonise you in a way that isn't going to cost anything, that is going to be, as I say, ultimately profitable. So your cost per tonne of CO2 abated is positive, or negative rather, and your cost per tonne of aluminium produced goes down. So why wouldn't you? And so we get a really great response off the back of that.
Do you have an idea about how low you will go on the CO2 emissions if we implement this technology, for example, in a smelter? And also, do you have an idea about how big can you guys go with this loop technology? Because at the end, primaries, they produce tons and tons and millions of tons of aluminum every year. How easy is to get into those volumes?
That's a great question. So right now, as Ellie said, our first commercially available or scalable technology next year.
Okay.
We have line of sight right now all the way up to a loop 25,000 from a scale standpoint, but we're a number of years away from that. So unfortunately, at this, the best thing we can do is add more than one loop system. And as our technologies continue to roll out, we'll work with our partners and clientele to swap them out, so to speak.
Right.
So is we have a loop 1,000, when we come up with a loop 5,000 or 10,000, we can take some back, repurpose for other clientele, make things more cost effective, right? And at the end of the day, that's really our goal, is making this sustainable for people and cost effective. as Ellie mentioned, this doesn't need to be a detriment. We're trying to show people that their CapEx cost, we can show them an ROI that would make most bankers very happy. Well under 3 years, in some cases, well under a year to receive that ROI, and then turn it, as Ellie said, into an actual revenue stream, a profit share that'll really drive to the bottom line. And so if we can pull some of that equipment back that's been deployed, maybe it's only out there 1, 2, 3 years, sell that at a reduced cost to other users that can then use that to decarbonize, and for the client, give them a credit for the larger system. That's kind of the platform we're trying to roll out. We want to make it easy to say yes.
Right. And what are the challenges that you expect to have in order to get into those points from the technological point of view and from the, let's say, market approach? Because it's not easy. I mean, it's a great technology, the speech is great, but at the end, I think you are facing a lot of different challenges from the technological point of view, but also market introduction, right? How are those challenges, and how are you sorting those?
The technical difficulty with or challenges with scaling to a loop 25,000. But from the market standpoint, I don't believe it's going to continue to be as challenging. As long as we do that awareness campaign, I think what we're seeing is kind of that snowball effect, right? It's so real small, but as it continues to gain momentum, more and more people are looking at it, and we're just gaining larger followings. And so I'm not overly concerned over time with people's acceptance of it. It's just this initial how to get it up off the ground. And right now, Levidian is at the forefront of scalability. So we're doing it on a scale nobody else is, right? And from an efficiency standpoint, we still have a long way to go. But from a hydrogen production, our Loop 1000 actually uses less electricity to produce a kilogram of hydrogen than an electrolyzer.
Right.
So, and we're less than CapEx. So it's, there are some wonderful benefits where we're already at just at the beginning of scale. So, but Ellie, please.
I agree. I think scaling for me is not the worry. That's not the kind of the barrier that I expect to come across. Our technology is modular. There are different parts of it that we can scale in different ways to kind of create efficiencies, enable it to process more gas per hour, enable it to perform with kind of less electrical input per output. There's a huge amount that we can gain on the efficiency side, and actually scaling it up to do more is fine. For us, we do this loop system. It's the stuff either side of that. So how do you then? It's the coupling of that to the customer's kind of gas supply, making sure it's fed in at the right kind of pressure. And it's the things like, if you're delivering now hydrogen gas to a burner for a furnace, then is that burner that exists suitable for that, or does that need to be converted out as well? To be honest, I think those are just engineering problems that have solutions that can be solved. So we'll be working with partners, I think, on that side of things. And people who build foundries, people who build these facilities and anode production facilities, they know exactly how all of this stuff fits together. So I think for us to overcome those and to enter the market, we're going to need partnerships that help us to do that, that will work between us and the aluminium producer to deliver the whole solution in a way that works for everyone.
Right. And when you say modular, because we think that modular is something that you can just assemble very fast, but it's also something that you can grow if the process needed, so you can add more modules or whatever it is.
Yeah, so in our loop system, we have our kind of reactor chamber, and this to the methane gas produces the graphene and the hydrogen. We can, one, scale up those nozzles so that each one of those can kind of process more gas at any one time. Two, scale up the size of the reactor chamber and put more nozzles per chamber on it. So with each nozzle, we kind of multiply the amount of gas we can process, and then we can scale up by basically putting several of those reactor chambers in one unit or kind of one facility. So we can scale along several axes, and a lot of our internal resource goes into the R&D of that system and how we scale it up and make it more efficient.
I don't think we can stress this enough, and this goes back to what I was saying on, we can, as we continue our journey to scale and as we have different iterations released, we can take those away. When we talk about modular, these are literally shipping containers, sea cans.
Right.
that are 40-foot ISO. So these are, as you said, quickly deployable. They take up very little footprint, very serviceable, and we can change them out and redeploy the asset as the technology grows and expands, or as our clients' demand grows. We can continue to bolt on and add. So there's not a one solution fits all. We can literally tailor our equipment to the size of your facility, up or down, so we can expand or contract with your company depending on what's needed.
Nice. And what about data collection? Are you using any type of like IoT or 4.0 technology that allow the people or the customer to understand, hey, yes, I am reducing my CO2 emissions by this amount, I am reducing my energy or increasing my efficiency or whatever it is? Are you using this type of approach, or maybe AI or something like that? Why I'm asking? Because I am seeing more and more this technology approach on the recycling side. People more and more wants to know, hey, how much money I'm making right now, how much scrap I'm putting into my furnace, and how much liquid aluminum I'm taking out of the furnace, how much draws I am creating, everything that allow them to understand better the process is going right now. So are you having any type of approach for data collection?
So for us, it's fairly simplistic, right? You have X amount of weight of natural gas going in. We literally make it rain graphene down, and then it's
hydrogen is
natural gas, blend that goes out. Now, as Elliot mentioned before, we can actually loop, hence where the name came from, separate out the hydrogen from the reformed methane gas, and loop the methane back through to get 5/9 hydrogen for, a fuel cell or something else.
Right.
You can literally just take, X weight, Y weight of graphene, and then Z out, right? Which is just your hydrogen. So it's pretty simple for us to measure the amount of carbon savings, because you physically have a tote of carbon at the end. So again, we have not to date really gotten involved in specific countries or geographic incentives for carbon rebates, because every sector, every state, every country is different on how they want to quantify, calculate, and pay out. So really, for us to get into the weeds, we'll work with your team to help find that money, monetize, prove out. But we try to stay out of that specific value chain ourselves.
Right. Do you already have any system that is working that maybe you can just make some trials or whatever? Or is the system already working in any part of the world? Okay.
Yes, we have several deployed, which Ellie can speak to far greater than I can, worldwide, and then our first couple systems are going into the US here this year.
We had our biggest system delivered 2-3 weeks ago to United Utilities in the UK. That's a wastewater treatment company. Another one went off to Worthy Farm, which is where our Glastonbury Festival is hosted. So that one went off a few weeks before as well. And we've got several that are going out there. We've had one that's been operational in the UAE for quite a while now, good year and a half or so since that one was deployed. So these things are out there, they're working, they're being tested on different gas inputs, and we've got more going out there in the near future.
For how long you guys been working on this technology?
So we started out life actually as a graphene company. So we were spun out of Cambridge University in 2012, and that company basically performed a lot of graphene R&D, and they were making their graphene out of methane. And then a few years ago, new ownership came in, looked at what we were doing, when you equal hydrogen that some people might find valuable for some scenarios. You've got a different, business model there. So we containerized the whole system and kind of transformed the business into, brought in new leadership, people from the energy industry, and transformed it into more of a climate technology company. That's how we ended up where we are today.
What is the future? What we can expect from this technology and Levidian group getting to this more and more green wave that we are seeing right now? What is the future?
I think there's probably a lot of exciting things we can get into. I think one kind of touching on your AI point, one aspect of our development is to kind of monitor and modify the process as we go to potentially produce maybe different varied carbon that come out of the loop. So not just graphene, it could be different types of carbon at different volumes that are suited to particular applications that enable us to have a kind of fleet of units out there that are doing very different that kind of fit very differently to different kind of commercial scenarios. So I think as well as scaling, we'll be making the equipment a lot more smart and a lot more kind of AI driven, so that a customer could press a button and go, I don't want graphene today. I want carbon black or some other form of carbon.
Right.
That will be very exciting. And we can also look at, I guess, different gas inputs that we can crack. So we can start working on different gas mixes and processing that through our process, and really starting to kind of broaden the range of greenhouse gases that we could strip useful products out of and, turn into their own kind of loop version for different industries. And if you have any further thoughts on that, Matt, but that's the way I see it growing.
No, I think it's very, very well said. The one thing we possibly won't need here in North America, just due to the amount of natural resources from the energy industry we have, but in other countries, we might be able to actually start looking, again, at tailoring that gas output too. So producing more acetylenes, we can produce different gases outside of hydrogen coming out. We can enrich the gas as needed. So we could actually technically make somewhat customized gases as well, which goes right hand in hand with what Ellie was referring to, the future, where you could flip a switch essentially and create that carbon black, that graphite, or what have you.
Oh, that's very interesting because it's very flexible. At the end, it's not just
we're not there yet. That's the goal.
That's the future. That's the goal, right? Well, guys, I think what you have in your hands is something that can be, how we can say it, disruptive from the point of view of the sustainability and the industry approach to get green. And I think we will see more and more technologies like this one getting into a point that the industry really wants to implement these approaches, because at the end what we want is not to make all things better, but to change things on a radical manner in order to improve what we are seeing right now. And I think loop system is something that will make things different. And this is what I am thinking, because again, you are helping an industry that everyone on the recycling industry wants to go down, right? That is the primary sector. But right now with this approach, what I'm seeing is, why not to help the industry, instead to kill the industry, let's help the industry to make more aluminum so we can be more sustainable. Guys, I really appreciate all the time and effort you make to be here with us. And if you have a final quote to say right now, just give the people some more, information, where they can find you, and let's do it.
Absolutely. Encourage everybody to go to Levidian.com, have a look. Feel free to reach out to myself, Ellie, or the rest of our team. We'd be happy to engage with anybody. Julio, thank you very much for having us on and all the discussion. This is what a great platform, and we've, as we've discussed, enjoyed your podcast previously, and
thank you.
Look forward to them in the future.
Sure.
Thank you very much for having us on. It's been fantastic.
Oh, thank you so much, guys, and let's keep in touch, because definitely I want to have you guys later in the future when you have more developed on this technology and more things to say. Just let us know. And for sure, if in some point you can talk about the systems that you are putting here in the US in the future, just let us know. Let us know how those systems will behave, everything. We want to know about the evolution of this system. It's so cool.
Thanks, will do.
Thank you very much. And great
hat. Guys. Oh, yeah. I know. Representing, eh? Guys, thank you so much. Take care. Have a great day. And thank you for being here with us in the Dirty Scrap the Aluminum podcast.
Dirty Scrap Podcast.